Before we begin, do me one favor and subscribe, because the pattern I am about to walk you through is one that has already been blamed for dozens of deaths this summer, and it is not finished with the country yet. For weeks now, huge stretches of the United States have been trapped under domes of heat so intense that they have shattered decades-old temperature records, strained power grids, and pushed hospitals into heat emergency protocols. And here's the part almost nobody is talking about clearly enough. This is not one heat wave. It is a series of them, rolling across the country one after another, and the atmosphere is already lining up the next one. So stay with me, because by the end of this, you will understand exactly what a heat dome is, why this summer has produced so many of them, and what the coming days actually look like for the people living underneath this sky. Let's start with the basic question, because a lot of people hear the phrase heat dome on the news without ever being told what it actually means. A heat dome is not a cloud of hot air drifting in from somewhere else. It is created locally, right above the region that suffers through it, by the shape of the atmosphere itself. High above the surface of the Earth, several miles up, air moves in large, slow-turning patterns. When a strong area of high pressure develops and becomes anchored in place, it behaves like a lid settling down over a pot. Underneath that lid, air sinks. As it sinks, it compresses, and compressed air heats up the same way a bicycle pump gets warm in your hand as you push the air inside it down into a smaller space. That sinking, warming air also suppresses clouds and rain, because clouds need rising air to form, not sinking air. So a heat dome does two damaging things at once. It bakes the ground with sunshine that has nothing to block it, and it prevents the very storms that might have cooled things down from ever forming in the first place. Picture a pot of water on a stove with a heavy lid clamped down on top. As the burner heats the pot, steam rises and has nowhere to go. It presses against the lid, and the whole pot grows hotter and hotter because nothing can escape. Now imagine that lid is not made of metal, but of high-pressure air sitting several miles above a city, and the steam is the heat radiating up from streets, rooftops, and sun-baked fields. The heat has nowhere to vent. It just keeps building, day after day, until the lid finally lifts or moves somewhere else. That is essentially what has been happening over huge sections of the country this summer, one heavy lid after another, settling first in one region and then shifting to the next. This year has been a case study in exactly that pattern. In the days leading up to and through the 4th of July, a massive heat dome formed over the central and eastern United States. A broad area of high pressure developed beneath an upper-level ridge, and it stabilized and strengthened, trapping a much warmer, high-humidity air mass beneath it. The result was brutal. Over 165 million Americans in the Midwest and East found themselves at risk of major or extreme heat-related health issues during that stretch, according to the National Weather Service's own risk tracking system. And it was not just the daytime highs that made this dangerous. Combined with high humidity, heat indices approached or exceeded 105 to 110 degrees in many places, and overnight lows stayed unusually warm too, offering little to no relief even after the sun went down. That last detail matters more than people realize. The human body needs a break from heat to recover, and when nighttime temperatures refuse to drop, that recovery never happens. Day after day of no relief is far more dangerous than a single scorching afternoon. Then, just as that eastern heat dome began to ease, the pattern shifted rather than disappeared. A second heat dome began forming over the western half of the continent, bringing heat advisories to the southwest United States and even to Alaska. By that point, the death toll attributed to the summer's heat had already climbed to at least 44 people. Out west, the numbers were staggering. Forecasters warned that temperatures could soar well above normal, with some locations approaching or even surpassing their hottest temperatures ever recorded. Cities that rarely see triple-digit heat found themselves flirting with all-time records, and the dry conditions that came with it did more than just make people uncomfortable. The same high-pressure system that was baking the West was also worsening drought conditions and raising the risk of wildfire across the region, as dry thunderstorms with little rainfall moved through without offering any real relief. And then, only days later, the pattern rolled again. A new heat dome began expanding across the central and eastern United States, threatening to push AccuWeather's real field temperatures into the range of 105 to 115 degrees. Cities in the Midwest that thought they had already seen the worst of the summer were bracing for another round. Minneapolis, Indianapolis, Chicago, and Omaha had already reached into the 90s earlier in the season, and forecasters warned that daily records could be broken or seriously challenged again as this newest dome settled in. This is the part that should really get your attention. We are not talking about one bad week. We are talking about a summer where the atmosphere keeps rebuilding the same kind of lid over and over in different parts of the country, almost as soon as the last one lifts. Earlier this summer, the National Weather Service confirmed that El Niño conditions were present, with the possibility that it could strengthen into what some forecasters are calling a super El Niño as the year goes on. El Niño is a natural climate pattern involving warmer than average water, in a huge stretch of the Pacific Ocean, and it has a way of reshaping weather patterns across the entire globe, including the position and strength of the jet stream that steers heat domes into place. Some forecasts are even pointing to a rare combination this year, with the Super El Nino interacting with unusual conditions in the Atlantic, effectively building what meteorologists have described as an atmospheric shield over the United States and Canada. When a strong El Nino pattern sets up shop, it does not just cause a single heat wave. It tilts the odds of the entire season toward repeated, stacked, and intensified heat events, which is exactly the behavior we have been watching unfold since late June. There is also the deeper, slower-moving piece of this puzzle that never goes away, and that is the long-term warming trend. Heat waves worldwide have been becoming more harsh and more frequent because of human-caused warming from fossil fuel pollution. And scientists who study these events are consistent in pointing out that a warmer baseline climate does not create heat domes out of nothing, but it does make every heat dome that forms hotter, longer lasting, and more dangerous than it would have been decades ago. Think of it like this. A heat dome is the weather pattern, the lid clamping down over the pot. But climate change is the burner underneath the whole stove being turned up a notch, year after year. The lid was always going to form somewhere. But now, when it does, the water underneath it starts from a higher temperature than it used to. Now here is where it gets important for you, wherever you happen to be watching this from, because the story is not finished. As of the most recent forecasts, meteorologists are tracking yet another shift in this pattern. Forecasters expect the heat dome to strengthen again over the plains rather than weaken, potentially bringing an extended stretch of 90 to 105 degree temperatures across a wide swath of the country's midsection. The same system responsible for trapping wildfire smoke over the southwest has been flagged as capable of pushing record-high temperatures into the northern plains by the middle of the month. In other words, the lid that eased off the east is being rebuilt over the middle of the country, and depending on how the upper atmosphere behaves in the coming days, it could expand outward again toward the Great Lakes, the Ohio Valley, and potentially back into the Northeast, the same regions that were baking just weeks earlier. Let me be very clear and very honest here, because that honesty is the foundation of everything I do. I cannot tell you the exact high temperature your city will see next Tuesday. Nobody can, with certainty more than about a week out, because the atmosphere is a chaotic system, and small shifts in the jet stream can move a heat dome's boundary by hundreds of miles in either direction. What meteorologists can do, and what they have been doing all summer with real skill, is identify the broader pattern, the ridge of high pressure building where it is building, the direction the jet stream is steering it, and the odds that it strengthens, weakens, or shifts. And by every one of those measures, the pattern this summer has been unusually persistent. One heat dome fading has not meant relief. It has meant a short pause before the next one takes shape. It's worth taking a moment to talk about why this kind of heat is genuinely dangerous, not just uncomfortable, because I think a lot of people underestimate it simply because it does not look as dramatic on camera as a hurricane or a tornado. Heat is, in most years, the deadliest weather hazard in the United States, deadlier than floods, deadlier than tornadoes, deadlier than hurricanes, precisely because it kills quietly, indoors, in cars and homes, without air conditioning, and among people who do not always realize how much danger they are in until it is too late. The human body cools itself primarily through sweating, and sweat only works as a cooling mechanism if it can evaporate off the skin. When humidity is high, as it has been through much of this summer's heat, sweat cannot evaporate efficiently, and the body's main defense against overheating essentially stops functioning. That is why the heat index, the feels-like temperature that combines heat and humidity, matters so much more than the raw thermometer reading. A 95-degree day with high humidity can be more dangerous to the human body than a dry 105-degree day in the desert. The people most at risk are not always the people you would first picture. Elderly individuals are especially vulnerable because the body's ability to regulate temperature and sense thirst naturally declines with age. Young children overheat faster than adults because their bodies have a larger surface area relative to their mass. People with chronic health conditions, particularly heart and respiratory issues, face serious strain because the body pumps more blood to the skin to try to shed heat, which puts extra load on the cardiovascular system. And then there are the people who simply cannot escape the heat because of their circumstances. Outdoor workers, people experiencing homelessness, and households without reliable air conditioning. During the peak of this summer's heat events, infrastructure itself began to strain under the demand, with power outages and hospital cooling issues reported in major urban areas as air conditioning systems ran non-stop and electrical grids struggled to keep pace. When the grid strains, the danger compounds, because the very systems people rely on to survive the heat become less reliable exactly when they are needed most. There's a term that has entered the public conversation more and more in recent years, and it is worth explaining properly because it shows up constantly in these forecasts. A heat dome forms when a ridge of high pressure in the upper atmosphere becomes unusually strong and critically unusually stationary. Weather patterns normally move. A ridge of high pressure typically drifts across the country over a matter of days, giving way to the next system behind it. But when the broader pattern in the jet stream becomes distorted, sometimes described as a blocking pattern, the ridge can lock into place for a week, 2 weeks, or even longer, refusing to budge. That stubbornness is what turns an ordinary warm spell into a genuine heat dome capable of setting records. It is the difference between a hot day passing through and a hot system parking itself directly over your head and refusing to leave. This is also why you will sometimes hear meteorologists talk about the jet stream almost like it is a living thing, wobbling and bending and buckling. The jet stream is a narrow river of fast-moving air several miles up that generally flows from west to east and acts as the boundary between cooler air to the north and warmer air to the south. In a normal, healthy pattern, the jet stream flows in relatively gentle waves, allowing weather systems to keep moving along at a reasonable pace. Let's talk about what actually happens on the ground when one of these domes settles in, because the effects ripple out far beyond just a hot afternoon. Asphalt and concrete in cities absorb enormous amounts of heat during the day and radiate it back out slowly through the night, which is part of why urban areas often stay far hotter after dark than the surrounding countryside, a phenomenon known as the urban heat island effect. This means that people living in dense city neighborhoods, particularly those with less greenery and more pavement, often experience even more dangerous nighttime conditions than official regional temperature averages would suggest. Meanwhile, out in drier regions, the same high-pressure ridge that traps heat also dries out vegetation and soil, priming the landscape for wildfire. In some cases this summer, the powerful winds accompanying a shift in the heat dome's position have intensified already dangerous fire weather conditions, complicating the work of firefighters battling blazes that were already burning. Heat, drought, and fire are not three separate stories. During a summer like this one, they are three chapters of the same story. There is also a strange irony buried inside all of this, and it is worth pointing out because it trips people up constantly. A heat dome over one part of the country can sometimes coincide with severe storms or even flooding somewhere nearby, because the boundary of the dome, the edge where the hot trapped air runs into cooler, more unstable air outside the ridge, can become a breeding ground for intense thunderstorms. While one part of the country cooks under the dome itself, the shift in the jet stream driving that dome can simultaneously bring a significant cool down, along with powerful winds, to another region entirely. So the same weather pattern that bakes one city can, at the very same time, be soaking or battering another. This is part of why national heatwave coverage can feel confusing if you're only half paying attention. The story is never uniform. It is a shifting map, with some regions inside the dome and suffering, and others sitting right on its edge dealing with an entirely different set of hazards. So where does that leave us right now, heading into the days ahead? Based on the pattern forecasters have been tracking, the core of the heat is expected to keep shifting rather than disappearing. The ridge that eased off the east has been rebuilding over the central United States, with the plains and the Midwest positioned to bear the brunt of the next surge, and there remains real uncertainty about how far east that heat ultimately pushes. Some forecast models suggest the hottest air stays anchored over the interior of the country for an extended stretch, while others suggest at least a partial eastward expansion is possible if the ridge shifts again. I want to be just as honest about the uncertainty here as I was earlier about the mechanics, because overconfidence is exactly what leads people to either panic unnecessarily, or worse, to underestimate a real threat, because a specific prediction turned out to be a little off. No forecaster can promise you an exact temperature for a specific day 2 weeks from now. What they can tell you with real confidence is the shape of the pattern, and right now that shape says the atmospheric conditions favoring heat domes are not going away. The Super El Nino influence some forecasters have flagged is not a short-term blip. It is a seasonal scale pattern that tends to keep reasserting itself over weeks and months, which is exactly why some forecasts are already extending this outlook, mentioning influence stretching toward a warmer than typical fall and an unusual winter pattern later in the year. That is the atmosphere telling us, in its own language, that this is not a fluke week. It is a season with a theme. Let me walk you through what preparation actually looks like, because unlike an earthquake, which strikes without any warning at all, a heat wave is one of the few natural hazards you generally see coming days in advance, which means there is real, meaningful action you can take before it ever arrives. First, take the forecast seriously in the days before a heat dome is expected to build over your area, not just on the day it peaks. Extreme heat watches and warnings are typically issued well ahead of time specifically, so people can prepare rather than react. Second, if you do not have reliable air conditioning, identify a cooling location near you in advance, whether that is a library, a shopping center, a community center, or a friend's home, rather than waiting until the hottest day to figure it out. Third, hydration matters more than most people think, and it needs to start before you feel thirsty. because thirst is already a sign that your body is behind on fluids. Fourth, check on elderly neighbors, relatives, and anyone you know with health conditions, because so many heat deaths happened quietly, alone, indoors, to people who did not realize how serious their situation had become. Fifth, never leave children or pets in a parked car, even for a few minutes, because the interior of a vehicle can climb to dangerous temperatures far faster than most people expect, even on a day that does not feel like the hottest of the summer. And finally, if you must be outside during the hottest part of the day, pace yourself, take breaks in shade or air conditioning, and recognize the early symptoms of heat exhaustion, which include heavy sweating, weakness, dizziness, nausea, and a rapid pulse, so that you can act before it progresses into heat stroke, which is a genuine medical emergency. There is something worth reflecting on here beyond the forecast itself, and it is the way this kind of hazard tends to hide in plain sight. A hurricane gets a name, a spiral shape on satellite imagery, and days of dramatic coverage. A heat dome gets a shaded red or purple blob on a temperature map, and a headline that people scroll past because, on the surface, heat feels familiar. Everyone has experienced a hot day. But familiarity is exactly what makes this hazard so dangerous, because a genuinely extreme, sustained heat event is not simply a hot day stretched out. It is a fundamentally different kind of stress on the human body, the power grid, the water supply, and the landscape, and it kills more people in a typical year than almost any other weather disaster in the country, quietly, without the dramatic footage that other disasters generate. Part of the reason to walk through those mechanics of this so carefully is to move it out of that false familiarity and into the seriousness it actually deserves. It also helps to step back and remember that heat waves are not new to this country, even if this particular stretch feels unusually relentless. The United States has weathered severe multi-week heat events before, some tied to strong El Niño years in the past, some simply the product of a stubborn blocking pattern locking into place at the wrong time. What makes the current moment different is not that heat domes exist. It is the combination of factors stacking on top of each other this year: a strengthening El Niño pattern, a warmer long-term climate baseline, and a jet stream that keeps rebuilding the same kind of blocking ridge again and again, rather than allowing the country a clean break between events. That combination is what has turned this into not just a heat wave, but a heat wave season, with one dome handing off to the next, almost before the previous one has finished making headlines. It's also worth understanding why some cities get hit so much harder than others, because the same heat dome does not affect every location equally. Geography plays a bigger role than most people assume. Cities built in low-lying river valleys or basins, for instance, tend to trap heat more stubbornly than cities on open plains, because the surrounding terrain blocks the kind of air movement that would otherwise help flush warm air out. Coastal cities often catch a break that inland cities do not, because a sea breeze can push in cooler ocean air during the afternoon, shaving several degrees off what would otherwise be a punishing high. That is part of why, even within the same broad heat dome, you can see a 20-degree swing in how brutal conditions feel from one metro area to the next, all depending on elevation, distance from water, and how much of the surrounding landscape has been paved over. None of this makes the forecast easier to predict down to the degree, but it does explain why your cousin 2 states over might be living through a completely different experience than you are, even while both of you are technically sitting under the same enormous ridge of high pressure. There's another layer to this that deserves attention, and it's the strain that repeated heat domes place on infrastructure that was never designed to handle back-to-back extreme events with so little recovery time in between. Power grids are built with a certain amount of headroom for peak demand, calculated using historical patterns of how hot a typical summer gets and how often. When a single heat dome pushes demand to a seasonal peak, most grids can usually handle it. But when that peak is followed just days or weeks later by another dome demanding the same or greater load, equipment that would normally get a chance to rest and be inspected instead keeps running under continuous strain. Transformers overheat, maintenance windows get pushed back because crews are busy responding to outages rather than performing preventative work. This is one of the quieter risks buried inside a summer like this one. It is not just about whether the grid survives any single day of extreme demand. It is about whether it can keep surviving that demand over and over, dome after dome, without the kind of downtime that normally lets a system recover. Water systems face a similar kind of compounding stress. During extended heat events, water usage climbs sharply as people run air conditioning units that rely on evaporative cooling, fill pools and water lawns and gardens in an attempt to keep vegetation alive through the dry stretch that so often accompanies a stubborn ridge of high pressure. In regions already dealing with drought conditions worsened by the same weather pattern driving the heat, that spike in demand can collide directly with shrinking supply, forcing local governments to introduce restrictions, right when residents feel like they need water the most. Agriculture takes a hit too, and this is a piece of the story that often gets lost once the headlines move past the human comfort angle. Crops that are stressed by extended heat and inadequate rainfall produce lower yields, and livestock face their own serious heat stress risks, sometimes severe enough to cause real economic losses for farmers and ranchers in the affected regions. A heat dome, in other words, does not stay contained to the question of how hot it feels standing on a sidewalk. It reaches into the food system, the water system, and the electrical grid all at once. I also want to touch on something that meteorologists have started paying closer attention to in recent years, which is the way these heat events interact with air quality. When a ridge of high pressure parks itself over a region for an extended stretch, it does more than trap warm air. It also traps pollutants closer to the ground, since the same sinking, stable air that prevents clouds and rain from forming also prevents the usual mixing that disperses smog and particulate matter upward and away. Combine that with wildfire smoke drifting in from fires burning in drought-stricken areas nearby, and you get stretches where the air itself becomes an additional health hazard layered on top of the heat, particularly dangerous for anyone with asthma or other respiratory conditions. This is part of why some of the same forecasts tracking heat dome development this summer have also been tracking smoke transport from ongoing wildfires, because the two hazards so often travel together, riding the same stagnant weather pattern. So let me pull this all together into what really matters. First, a heat dome is created when a strong, stationary ridge of high pressure traps warm air beneath it, and this summer that ridge has repeatedly rebuilt itself in different regions rather than breaking down for good. Second, this year's pattern has been intensified by an unusually strong El Niño, one some forecasters are already describing in super El Niño terms, layered on top of a long-term warming trend that raises the baseline temperature every heat dome starts from. Third, the danger from this kind of heat is not limited to daytime highs, since high humidity and warm overnight lows prevent the human body from ever getting the recovery it needs, which is exactly what has made this summer's heat so medically dangerous. Fourth, the most recent forecasts show the ridge rebuilding over the central United States, with real potential to expand again toward regions that already endured a brutal stretch weeks earlier. And fifth, unlike many natural hazards, this one gives real advance warning, which means the single most important thing anyone can do is take the days of notice seriously, rather than waiting for the hottest afternoon to start preparing. And yet, with all of that said, I want to end on the same honest note I have carried throughout. This is not a prediction of doom, and it is not a claim that every single day ahead will bring record heat to every corner of the country. Weather patterns shift, ridges eventually break down, and cooler air always finds its way back in eventually, the way it always has. What the evidence clearly shows is that the atmosphere over the United States has spent this summer locked into a pattern that keeps regenerating extreme heat, region by region, and every indicator forecasters are watching suggests that pattern has not finished playing out. Nobody can tell you the exact day relief finally arrives for good. What we can do is understand the pattern, respect what it has already shown us this summer, and prepare wisely for what is very likely still ahead. If you are somewhere in the path of this heat right now, the preparation is straightforward and it is worth doing today, not on the day the warning is issued. Know the signs of heat exhaustion and heat stroke, and know the difference, because heat stroke is a life-threatening emergency that requires immediate medical attention. Stay hydrated throughout the day rather than catching up after the fact. Check your air conditioning now before a surge in demand strains the grid during the peak of the next dome. Check on the people around you who are most vulnerable, the elderly, the very young, and anyone managing a chronic illness, and treat the advance warning that meteorologists give you as the gift that it is, because unlike so many natural disasters, this is one where you genuinely get to see it coming. The heat dome that battered the east around the 4th of July has already handed off to the next one, and the one building over the central United States right now looks ready to hand off again. The atmosphere for now keeps rebuilding the same kind of lid over the same overheated pot. When that pattern finally breaks for good is something only the coming weeks will tell us, but that the country is not finished with this heat, not yet, is about as close to certain as a forecast gets. I will keep following this pattern closely and bringing you clear, honest updates as the forecasts sharpen. If you found this valuable, let me know in the comments where you are watching from and whether the heat has reached you yet. Take care, stay cool, and I will see you in the next one.